All right, going on to 10.6, logarithmic functions, where logarithms are exponents. Logarithms and exponents very much connected. So the first couple of questions here, we want to change from log form to exponential form. So the main thing to remember here is that when you see this expression, log base b of x equals y, that means exactly the same thing as this base being raised to this exponent, giving this result. So these are equivalent statements. Okay? This is called log form, and this is called exponential form. So you want to be able to go back and forth, given this form, be able to write it in exponential form, given exponential form, be able to change the log form. We're going to use this idea to solve logarithmic questions and equations also. So first things first, in your book, on number 6, you have this given, and you're asked to change it to log form. Well, first of all, this is not true. This is a misprint in your book. 3 to the 5th does not equal 729. 3 to the 5th equals, I believe, 243. 3 raised to the 5th is 243. So notice that number 6 on page 610 is a misprint, and this is not true. This should actually be 243, or 3 to the 6th equaling 729, but we'll keep it like this. So we have been given the exponential form, we just want to change to log form. So all we do is say logarithm, the base is the base of the term here, 3. The result is 243 when we put an exponent of 5 onto that base. So this is your answer for number 6 after we fix the misprint. Okay, log form, exponential form. Base raised to this exponent gives this result. Okay, now the opposite direction, given logarithmic form and asked to put that into exponential form. So once again, we just said it. This base raised to this exponent gives this result. Base of 4, exponent of 3, result 64. 4 times 4 is 16, times 4 is 64. That one is correct. All right, now we also want to answer questions like number 20 and 28. So remember, if you don't see a base, a logarithm without a base written, that's logarithm base 10. Okay, we call that the common log because it's common. And we have a button for that on our calculator. And the only buttons we have on our calculator are log, which is log base 10, and ln, which is log base e. Okay, those are the only two we have on our calculators. So we use those a lot. So this is log base 10. And another incredibly helpful little relationship is this. If we can create this situation, say logarithm base b, and have the result be b raised to some exponent. Well, again, think about what we're asking here. We're saying what exponent, this is the exponent, that I put on this base to get this result. Well, it's just going to be x, right? So if we can create this situation, our answer is staring us in the face right there. Okay, so if we can do this, we're going to try to create this situation, because then the answer to that question is already there. It's just x. Right? So that's what we're going to do here. We're going to realize that 0.001 is 1 over 1,000, right? This is tenths, hundredths, thousandths. So we can write this as log, and we know it's base 10 of 1/1000th, right? Well, it's base 10. So what we just looked at, I can now rewrite this as log base 10, and we know 1/1000 is 1/10 to the third, right? 10 times 10 is 100, times 10 is 1,000. So 1/1000 is 1/10 to the third, which we know from our negative exponent rule is 10 to the negative third. So I can write this as log base 10 of 10 to the negative third. And once I do that, I have exactly what we were just talking about, logarithm base b of b to the x. We don't see the base of 10 here, but we know there's a base of 10 because we don't see it. So it's log base b of b to the x. And now our answer is just that x using this here. Right? So this is a very helpful expression that you want to familiarize yourself with. And again, lastly, this is a logarithmic equation. You're asked to solve this logarithmic equation. You want to solve for x. Well, again, we're going to use the relationship between log form and exponential form. If we change this to exponential form, we know the base is 8, the exponent is -2, and that's what we're looking for. We're looking for that result. Base, exponent, result. Base, exponent, result. Well, we know negative exponents again. This is 1/8 squared. 8 squared is 64. So our answer is 1/64 is going to be our answer. And you can check that and raise 8 to the negative second and make sure you get 1/64. All right, so those are some examples of changing from exponential form to log form, changing from log form to exponential form, using our properties of logs to figure out what this is. We're basically saying, what is this? What value is that? So we rewrite this as log base 10. We know it's a base 10. 001 is 1/1000, which we know is 10 to the negative third. That gives us our answer of -3. We change from log form to exponential form to solve that equation for x.